together and I have pleasure give you some information concerning Egyptian flints. It's interesting and important because most of scientists, most of tourists, if they talk about Egypt, they think about pyramids, they think about tombs, gold, and various important dynastic objects. But before, in Egypt, lived people, and they used for life, for work, various implements made of flints, not only but of flints. And because of this, I like to tell you some informations, give you some informations concerning Egyptian flints. First of all, primary deposits, this means limestones, Theban limestones, where are flints, many levels of flints of various colors, various shape, and various structures. We will start from a region of West Theban, so we are between King's Valley there and Temple of Hatshepsut and Thutmose III. It's important area for archaeology, and I did examination of the profile of Theban limestones, collecting samples from number 1 up to 28, going down from this top of Lassim mountain, down, and there is about 28 horizons with flints, with various flints. And it's, of course, primary deposition, Pliocene rocks and deposited in limestones deposited in the sea, and layers of concentrations of flints. There is excavation of Professor Niwiński. We look for tomb of Herhor many seasons, and by the way, I did observation of profile. There are limestones, of course, and there are horizons with flints. Horizon number 48, 40B, and 14 and 16. Why there is no 15? 15 is at other place. It's not continue to this place of this excavation. Workers are digging, looking for tomb of Herhor. And in limestones at the bottom of the profile we have this type of flints, of course organic origin, size up to 10 centimeters, sometimes bigger, composed of chalcedony and quartz mostly, sometimes opal. And going down from the top of Lassim to the deepest part of the profile, we have these types of flints. There is one after one horizons collected and plates polished of various kinds of flints. As you see, are slightly pink and green and brown and dark, very dark, with structures, organic structures, lamination, and so. All these flints were examined mineralogically. This I tell you later. But at the beginning there are macroscopic pictures because this is primary deposition, and all these kinds of flints we may find in secondary deposits in the gravels of Nile and surrounding rivers, empty now of course, but before they conducted water. So even in front of one of erems localized at tomb number 1152, we have pavement done using using flints, and these flints are typical representing horizon number 26. Under microscopy we have various pictures of flints from Lassim, from these Theban limestones, starting from a mixture of chalcedony and small grains of quartz. There is the scale. The pictures are taken using polarizing light microscopy, and relics of organic structures are present, sometimes opaque minerals like pyrite, and sometimes some kinds of flints contain inclusions of calcite, chalcedony, and quartz, and calcite, indicative component, and some, especially at the bottom part of the profile, there is chalcedony with mineralized relics of organisms, skeletons, silicified, substituted by quartz. And this is classical profile of limestones with many horizons, many horizons of flints. And secondary deposits of flints are everywhere on the surface. And we did excursion from Cairo to Ain Sokhna, and by the way we visited Jebel Hashab with petrified wood, and around this place we collected a lot of various kinds of flints at secondary position, gravels or pebbles, and I show you some now. Starting from not too much changed, not oxidated. They look like these. They are gray. Minerals coloring the flints are represented mostly by iron sulfides, so pyrite, and because of this flints are gray, of gray color, but on the surface where we have patina, and these sulfides are oxidated to sulfides, and the flint is changing the color. So often inside of flint color is other than the color outside. Next, there are with concentric structures of various composition, mineral composition, sometimes oxidated to brownish color, with cortex. Some flints contain still cortex. And next stage, there are flints oxidated. This is a group of flints from the bottom part of primary profile. At the primary position, these parts are green, dark green, gray, and so on. But after oxidation, they change color to black or brown, black. Often in this inside of flints are seen structures, various structures. There are relics of primary biological structures of sponga. And very strongly altered, oxidated flints are very dark, near black, as you see, with very very diversified internal structures, spots, lines, circles, etc., concentric, for example, and all these materials are very good for napping. Each was of this type was used for the napping, for preparation of implements. Under polarizing microscopy, some selected flints, because it's not possible to show all types under the microscopy, this will take a long time, so there are selected pictures. You see chalcedony and crystals of quartz secondary. Why I show you this? Because these structures, internal structures, are deciding about possibility of napping. Some structures are not, internal structures of flints are not good for napping, some other are very good for napping. So of course in the past people did not know about these structures inside, but they tested, they tried to nap, and they observed the results of napping, and later when they knew that it's good for napping, they start to produce blades or chips, etc. In some of flints from desert there is a lot of dark minerals, and sometimes in this background one can observe nice colored traces of carbonates. Now some words about utilization of these various napping material, raw material. We will start from Paleolithic site. It's many, but as example is Asasif, Upper Egypt, near of Deir el-Bahari, and this is this hill, so-called Asasif. Behind this there is village Kurna, and each of these blue arrows show place where we have implements, Paleolithic implements. So there are workshops, and there are characteristic because of the color. From long distance on the slopes of Theban hills are seen black spots, smaller, bigger. Each of these spots is workshop where prepared Paleolithic implements, and because of long time isolation, activity of sun, flints are covered with patina, and this patina is dark, and because of this on light limestones are seen dark spots representing Paleolithic, even very old stages of Paleolithic, but implements are still well preserved. Now some words about patina. There are pictures of various flints near the surface, and we have scale 100 micrometers, and it's seen that this color patina is localized mostly on the surface of flint. Inside flints has other color, and it's well seen that some flints were patinated in stages, and because of this kind of lamination of patina there and there, etc. How this process develops? During the night, where it's relatively cool, it's called the stones are covered with the traces of water which is penetrating down to the flint. And during the day, where sun is operating very strongly, this surface is heated, and the water, together with rests of elements dissolved in this water, is migrating to the surface, and water is evaporated, and elements, mostly iron, manganese, are deposited on the surface. And this mechanism is repeated thousands and thousands of times, especially on old implements, on surface of old flint implements. Sometimes there are rare cases where flints are covered with light patina, but this is because of a very special condition when these elements removed from the central part of flint are migrating not up to the surface, but crystallization starts below the surface of flint, below. And we have various stages of patination, various concentrations of coloring minerals, and because of this it's possible to see this zonation. Older flints, older implements show darker colors, younger are light. When we look to this chemistry of the patina, there are examples. We have concentration near of the surface or even on the surface of flints, implements, old implements, iron oxides. Sometimes there are accompanying elements, calcium, sometimes there is sulfur, sometimes there is manganese, sometimes is manganese, and there are examples of various types of patina, and according to various colors, if this patina is light, concentration of iron oxide is smaller. If it's very dark, the concentration of iron is high. And now something about Neolithic and dynastic implements. On example from Tel El Farha archaeological site in Delta, and we have small cores. There is 5 millimeters, so cores are 2, 5, 10 centimeters maximum. I will not talk about napping, way of napping at so, but our traces of napping are well seen. And various kinds of flints, implements made of various kinds of flints. Each of these flints was examined in Krakow, in Poland, and have his list of data: chemistry, mineralogy, granulation, crystallization, etc. I show you at the end of this presentation some informations, examples. And there are blades of sickles made of the same flint, but transparency of flint deciding about the color. These pieces are these blades are slightly thicker, and because of this are darker, and these are thinner, and they are transparent, and the color is light. Together with flint in Tel El Farha, there was not too much, but there were small agates, sometimes napped too, but these pieces are natural mostly. Together with flints inside are discovered flakes of other materials like quartzite, and these quartzites are evidently from the area of Jebel Hashab, about 30 kilometers to the east from Madi, from Cairo, and various types of these quartzites, very good for knapping. In Delta there is no other raw materials, so they use what was possible. And this piece is very interesting because this is piece of diabase, and diabase we have only in East Desert and in Sinai veins of basalt, and this piece is probably from area of Sinai, mostly central and southern, because at the north part of Sinai we have light sedimentary beautiful rocks. At this southern part we have magmatic, metamorphic, and diabases, magmatic veins of diabases, and this is document that the material was transported from this area too. And some pictures of implements done using scanning microscopy, and the edges of implements of various degree of utilization. This is edge with traces of utilization, not very strong. This part is damaged and is evidently documenting picture that this implement was used very much. And again, this part, this flint was again documentation. Photo is documenting the strong utilization of the implement. Generally, these materials are very good for examination using scanning microscopy. Now some words concerning methods of the examination and comparison of flints. There are results of examination of flints from Deir el-Bahari, yellow reddish flint, and you may see all data, macroscopic features, microscopic mineral composition, grain size composition, and chemical composition, with two groups of elements which are present in higher quantity and smaller quantity accompanying elements. All these elements were used for the comparison of data, and using computer program we prepare all these features of one flint are compared with features of selected other flints. Because of this, we are able to say if flint from this site is similar to flint from outcrop, and what is the degree of similarity. In this program, data are introduced to this program using special key, and next is chance to make comparison of materials from sites, between sites, and between site and outcrops, etc. And for example, is obtain similarity. For example, flint number 1 from Tel El Farha, Egypt, Tel El Farha, and Egypt from Jebel Hashab. The similarity of these two flints, flint modification 16 and flint number 1, so it's complicated. Similarity is 64%, and this similarity suggests that maybe flint number 1 from Tel El Farha implement made using flint number 1 was collected from area of Jebel Hashab, east from the Cairo. Using this computer program, we obtain a list of the similarity of samples of flints from one side to other flints from other side, and similarities obtained in percents, starting from highest similarity to lowest one. And because of this is chance to say something about localization of the sources of material collected by peoples. In Tel El Farha in Delta there are no primary deposits, there are no secondary deposits, because there are first of all silts of Nile, so all materials used for preparation of implements were imports from surrounding area. And this example showed that flint number 1 is most probably, maybe not exactly from Jebel Hashab, but from eastern desert of Egypt, localized east from the Mahdi, east from about 30 kilometers east from Cairo. So that's all what I'd like to tell you about Egyptian flints. Of course, its knowledge is much larger, but this is example. Maybe this data will be useful for prehistorians working on flints, on raw materials, because there are no examinations, there are no data concerning these primary deposits present in Theban limestone, as well as about flints present in at the secondary position at the gravels of lowland, not in mountains. So thank you, and I invite you for next my lectures, small lectures. Thank you, and have a nice time.